All right, so I want to show you how to do two-step problems today. Go back over that because a few of you are having a little trouble with that. So in the problems, you have the side that has the given units, and you have a side that has the desired units, what you're trying to get to. So the first step is realizing that you have a two-step problem. You will know you have a two-step problem because on both sides of the equal, you have a prefix. So I have centa as my prefix on this top problem, and kilo is my prefix in this top problem. And so they're on both sides of the equal sign. So my first step is to write down that I need two conversion factors. So there's conversion factor 1, bar, there's conversion factor 2. The next step is going to be writing down the units and the given number. So I'm taking 981.35 centigrams, and then I'm going to write down my desired units where I'm trying to get it to go to, so that kilograms is going to go on the top right. All right, my next step is to take my units that are given here, and I'm going to write them down here. Because mathematically, when I do the math, I need those two units to cancel because I no longer want centigrams. Now, on my conversion factor over here, centigrams is going, because this is a G, this will be a G, this will be a G. All right, so I have 1 centigram equals 0.01 grams. So in my conversion factor, I can't go straight to kilograms because my conversion factor says 1 centigram equals 0.01 grams. So I have to go to grams. I don't want grams anymore, so I'm going to get rid of the grams by writing it diagonally down. So when I do my math, the G's will cancel out, the centigrams will cancel out. Now, I've got all of my conversion factors set up with their units, and I would recommend that you make sure you write all your units down when you're doing these problems. The next step is to use the conversion factors to determine the numbers that go in front of your units. So my conversion factor says 1 centigram equals 0.1 grams. So the 1 goes in front of the centigrams because on my conversion factor it has a 1 in front of CG. The G has a 0.01, so I will write 0.01 in front of my G of my centigrams. Now, I need to do the same thing looking up the kilo here. So I go over to my conversion factors, find kilograms line, and it says 1 kilogram, because that's what the base is, equals 1,000 grams. So notice that the 1 is in front of the kg. So when I go to write this down on my conversion factor over here, I put a 1. And then the 1,000 goes in front of the G because that's what my conversion factor said over here on the side. All right, so now the math on this is just multiplying everything across the top. This is actually understood on the top, that 981.35 centigrams. So the math is going to be 981.35 times 0.01 times 1, and I'll get an answer. And then I will divide it by 1 times 1,000, okay, because that'll have to be in parentheses. 1 times 1,000 when you type that in your calculator, which is just 1,000. So I'm going to take whatever I get from the top and divide it by 1,000. My grams are going to cancel out. My centigrams are going to cancel out. And my answer is going to be kg. So you have to watch how you type this in on the calculator because of the way it does order of operations. All right, so this should be 9.8135 times 10 to the negative 2, which is 0.098135 kilograms. for your answer. 10 to the negative 2. I'm just checking my work just real quick, because that would be 0. Nope, that would be a 3, and there we go. That's actually the right answer, to the negative third power. Okay, on the next problem down here, we have 2.98 nanometers. And I'm going to decameters, so I have two prefixes, so I'm going to write this down. I would recommend getting your units in first. I'm going to write what's given. So my nanometers go here. Decameters is my desired unit, so it's going to go up here on top. And they both have meters in common, plus my conversion factors up here only have, see, nanos right here. And decameters is right here. Those two lines are the ones that I'm going to use. And notice that it's only got decameters to meters and nanometers going to meters. I don't have a nanometer going to a decameter. So this has to be a meter, and then I want to get rid of it by writing the meter down on the other side. All right, now I need to use my numbers, and so I use this nano line here, and it says 1 nanometer equals, I'm going to write this out in scientific notation instead of writing out a billion, 1.1 times 10 to the negative 9th power. And then decameters up here is 1 decameter, because there's the 1 in front of deca, equals 10 meters. I'm going to write that like this. All right, so when I do my math and you type it in the calculator, it's going to look like this. You're going to go 2.9, use your exponent feature. This could be a second EE on your calculator. If you're in class and you're using my calculators, it's an exponent button. 8, and then you're going to multiply that times 1 exponent negative 9, and then of course times 1, and then hit equals, get an answer, and divide it by 1 to the exponent 1. All right, so when you're doing scientific notation, if you didn't want to use a calculator on this, you would go 2.9, and then it's 8 plus this negative 9, which would give us a negative 1 exponent on the top. And then you would be subtracting by that 1 on the bottom. So I should have a negative 2. So my answer on this is going to be 2.9 times 10 to the negative second decameters. And my meters and nanometers cancel out, and that leaves this there. So I hope you see that on this chart, okay, on this chart, every prefix has a 1 in front of it. So it doesn't matter if you're doing a 1-step or a 2-step problem, wherever the prefix is on the problem, whether it ends up on the top or the bottom, it's always going to have a 1 in front of it. And the unit that's by itself, which would either be an M, a G, or an L, is going to end up with some power of 10 in front of it, because this stands for meters, this stands for grams, and this stands for the base unit, liters. And so if you have one letter by itself in the conversion factor, it will get one of these powers of 10 that are on this side of your conversion sheet. Okay, I hope that